Inside super strong material manufacturing technology. Super strong materials have become increasingly important for a range of applications, from aerospace to construction. These materials have the ability to withstand extreme conditions and stresses, making them ideal for use in a range of industries. The manufacturing technology of super strong materials involves the use of advanced materials and processes that can improve the strength, durability, and performance of materials under extreme conditions. One key material used in the manufacturing of super strong materials is carbon fiber. Carbon fiber is a lightweight and incredibly strong material, which is made by heating and stretching carbon filaments. The resulting material has high tensile strength, stiffness, and resistance to corrosion. Another key material used in the manufacturing of super strong materials is ceramics. Ceramics are inorganic, non-metallic materials, which can have high strength, hardness, and wear resistance. The manufacturing of ceramics involves the use of high-temperature processes, such as sintering and hot pressing, that can improve the strength and durability of the material. To manufacture super strong materials, advanced processes such as composite manufacturing are utilized. Composite materials are made by combining two or more materials with different properties to create a material with improved strength, stiffness, and durability. For example, carbon fiber and ceramics can be combined to create a composite material with high strength, stiffness, and wear resistance. In addition to the materials used, the manufacturing processes involved in the production of super strong materials are also critical to their performance and durability. Advanced manufacturing processes such as additive manufacturing, 3D printing, nanotechnology, and robotics can be used to create complex and precise structures that improve the strength and durability of the material. Moreover, the use of advanced simulation and modeling techniques can also improve the design and optimization of super strong materials by predicting their performance and behavior under different conditions and stresses. However, the manufacturing technology of super strong materials also faces challenges and limitations. One key challenge is the cost of manufacturing, which can be high due to the use of advanced materials and processes. Another challenge is the need for responsible and sustainable practices that ensure the environmental impact of manufacturing is minimized. Super strong materials are used in a wide range of applications, including aerospace, automotive, construction, and sports. They offer improved strength, durability, and performance compared to conventional materials, making them ideal for use in demanding environments and applications. One potential application of super strong materials is in the development of lightweight and fuel-efficient vehicles. By using super strong materials in the construction of vehicles, their weight can be reduced, which improves their fuel efficiency and performance. This can also reduce the environmental impact of transportation by reducing emissions and resource consumption. Another potential application is in the development of high-performance sporting equipment. Super strong materials can be used to create lightweight and durable equipment, such as bicycles, golf clubs, and tennis rackets, that offer improved performance and functionality. Moreover, super strong materials can also be used in the construction industry to improve the strength and durability of buildings and infrastructure. For example, super strong concrete can be used in the construction of bridges, tunnels, and high-rise buildings to improve their durability and resistance to corrosion and weathering. Looking towards the future, the potential applications of super strong